All right, so are you ready to get a little nerdy today?
Always.
Awesome. Because today we're going to be taking a deep dive into something that's absolutely essential to object-oriented programming.
Ooh, sounds exciting.
Yeah, it's called inheritance. And it's honestly one of those concepts that can really make your head spin if you're not careful.
Yeah, it can be a bit tricky at first, but once it clicks, it's like a whole new world opens up in programming.
Exactly. And to help us navigate this world, we've got a fantastic article. It uses some Java examples to illustrate how inheritance works.
Java is a great language to learn this with. It's very object-oriented.
Oh, yeah, definitely. And so to help us unpack all of this, I've got a resident code guru with me today.
Happy to be here. I love talking about this stuff.
So let's kick things off with maybe a relatable scenario to kind of set the stage for what inheritance is all about.
Okay, I'm game.
All right, so imagine you're designing a video game.
Ooh, I like where this is going.
Yeah. And in this game, you've got all these different types of enemies like goblins and dragons and zombies. Right now, each of these enemies has certain things in common, like health points and attack power.
Yeah, pretty standard stuff.
But would you want to write the code for those attributes from scratch for every single enemy type?
Oh, absolutely not. That sounds like a nightmare. Talk about repetitive code.
Exactly, and that's where inheritance comes in.
Oh, hero.
It basically lets you create these parent-child relationships between classes.
Hmm.
So you could have a parent class called enemy, which defines all the common stuff like health and attack.
Right, so it's like a template or a blueprint.
Exactly. And then each specific enemy type, like goblin or dragon, would inherit those properties from the enemy class.
That's so much more efficient. And it makes the code way more organized.
Right, so instead of copy and pasting the same code over and over again, you just say, hey, this new enemy type is based on this parent class, and it automatically gets all those basic attributes.
It's like magic, but it's actually just really clever programming.
Okay, so that's inheritance in a nutshell. Now, our source material uses Java to illustrate this concept, and it starts with this person class as an example.
Oh, yeah. Person is like the go-to example for explaining inheritance.
I'm kind of curious, why is that?
Well, think about it. Person is something we all understand. It's a concept that's very relatable. And there are so many different types of people in the world.
Sure.
You have students and doctors and engineers and artists. They're all people, but they also have their own unique characteristics and actions.
So using person as a starting point, it helps us see how inheritance can create this hierarchy of classes that kind of mimics how we think about the world.
Exactly. It's about modeling software in a way that makes sense to us humans.
Okay, so let's dive into this person class a bit more. What kind of attributes would a person class typically have?
Well, the basics would be things like name, age, and gender.
Okay, so those are like the nouns, the defining characteristics.
Right, and then you'd have the methods, which are like the verbs, the actions a person can perform.
So what would be some examples of methods for a person class?
Things like speak, eat, walk, maybe sleep.
Okay, I get it.
Yeah.
So we've got this person class with its basic attributes and methods. Now, what happens if we want to create a specialized type of person, like a student?
That's where inheritance really shines. We create a new class called student, and we specify that it inherits from person.
So it's like student is a branch on the person family tree.
Exactly. And just like that, student automatically inherits all those basic attributes and methods from person.
Without us having to write them all over again.
Exactly. It's like student gets a free starter pack of person stuff.
Okay, that's super efficient. And then on top of that, we can add attributes and methods that are specific to students, like student did major.
Yeah, and things like study, take exam, actions that are unique to being a student.
So it's like building upon that foundation we inherited from the person classes.
That's exactly what it is. It's all about building upon what's already there.
Okay, now I'm starting to see the real power of inheritance here. You're not only avoiding redundancy in your code, but you're also creating this really logical structure that mirrors how we actually think about things in the real world.
That's a big part of what makes object-oriented programming so powerful.
So we've talked about person and student. Our source article actually goes on to mention a bunch of other subclasses like doctor, engineer, even athlete.
All different flavors of person.
I'm guessing each of those would inherit from person and then add their own specialized traits.
Exactly. So a doctor might have attributes like specialty and methods like diagnose or prescribe medication.
And an engineer could have field off study and design bridge, or maybe something like write code.
Right. And you can see how this approach can be applied to all sorts of scenarios. It makes your code super organized and reusable.
Okay, so we've covered the conceptual side of inheritance. Now let's get a little bit more into the nitty-gritty of the code.
Let's see how this magic actually works.
Our source provides a snippet of Java code to show inheritance in action. And they've even included a link where you can check out the complete code, which we'll definitely put in the show notes.
Awesome. Definitely worth taking a look at. It really helps to see how all of this comes together in a real code example.
All right, so this Java code, it shows us how a student object can actually call the introduce yourself method, which is defined in the person class, even though it's not explicitly written in the student class itself.
It's like a secret handshake that only family members know.
How does that even work?
That's the beauty of inheritance. The student class, because it inherits from person, has access to all the public and protected methods of its parent class.
So it's like the student object inherits the ability to introduce itself from its person parent.
It's like a hidden superpower that subclasses get just by being part of the family.
And that makes the code so much more efficient because you
Yeah.
don't have to rewrite the same functionality over and over again for each subclass.
That's the name of the game in programming. Write less code, get more done.
I like that philosophy.
Oh.
So I think we've laid a pretty solid foundation for understanding inheritance. But there's still so much more to uncover.
Yeah, we've just scratched the surface.
We'll dive deeper into the benefits of inheritance and explore some more advanced concepts like polymorphism, abstract classes, and interfaces when we come back.
Can't wait.
So stay tuned. We'll be back in a flash.
So that hidden superpower, like you said, it's a great way to think about the benefits of inheritance.
Right. I mean, it's clearly more efficient to not rewrite the same code over and over again.
Absolutely. But it's not just about saving a few keystrokes. It also makes your code way more robust and maintainable.
Okay, so those are good things in programming.
Oh, yeah.
I mean, I get that it's good, but what do those words even mean in this context? Like, how does inheritance make code more robust?
Well, let's say you had to change something fundamental about all people in your program.
Okay.
Like, let's say you needed to add a new attribute like social security number.
Oh.
Without inheritance, you'd have to go through and manually update every single subclass like student, doctor, and so on.
Oh my gosh, that would be a pain.
It would be a nightmare. But with inheritance, you just update that one parent class person, and all the subclasses inherit that change automatically.
Oh, wow. So it's like a ripple effect.
Exactly. It saves you a ton of time and reduces the risk of introducing errors.
That makes a lot of sense. So inheritance isn't just a time saver. It's also a sanity saver for programmers.
Definitely. It helps you keep your code consistent and up to date, which is essential for large projects.
Okay, now our source material mentions something called polymorphism in relation to inheritance.
Oh yeah, polymorphism. That's a fun one.
It is. It's one of those words I've heard thrown around, but I'm never quite sure if I really understand it.
It sounds intimidating, but the concept is actually pretty simple.
Okay, I'm all ears.
Polymorphism basically means that objects of different classes can be treated as if they were objects of a common parent class.
Okay, can you give me like a real-world example?
Sure, let's go back to our person example. Right.
Imagine you have a method called greet that simply prints out a greeting message.
Okay.
Now, you could have different versions of the greet method for each subclass.
So like student might say, hey, what's up? And doctor might say, good morning, how are you feeling today?
Exactly. Different greetings based on the person's role.
Got it.
But with polymorphism, you can have just one greet method defined in the parent class person. And when you call that method on different objects, like a student object, a doctor object, they will each use their own specific version of the greet method, even though the method call looks the same.
So it's like the same action greeting, but with different flavors depending on who's doing the greeting.
Exactly. And that's what makes polymorphism so powerful. It allows you to write more flexible and adaptable code.
I'm starting to see how all these concepts, inheritance, polymorphism, they all work together to create this really elegant system for organizing and managing code. It's like building with Lego blocks. You start with these basic building blocks classes, and then you use inheritance and polymorphism to assemble them into more complex structures.
Okay, so we've got the Lego blocks. Now, what about the instruction manual?
What do you mean?
Well, our source material also mentions these things called abstract classes and interfaces.
Ah, yes, those are important concepts too.
I'm guessing they're a little bit more abstract than what we've talked about so far.
Pun intended.
Maybe.
Well, an abstract class is basically a blueprint that defines a common set of attributes and methods that its subclasses must implement.
Okay.
But the abstract class itself cannot be instantiated.
So it's like a template, but not a real thing.
Exactly. It's like saying, here's the general idea, but you need to fill in the detail.
Okay, I think I'm following it.
For example, you might have an abstract class called shape, with methods like calculate area and calculate perimeter. But shape itself is too general to be a real thing. You need to have specific shapes like circle, square, or triangle that inherit from shape and provide concrete implementations for those methods.
So shape is like the concept of a shape, and circle, square, triangle.
Mm.
Those are the actual shapes you can draw.
Precisely.
Okay, now what about interfaces? How are they different from abstract classes?
An interface is similar to an abstract class, but it takes it a step further.
Okay.
An interface defines a contract that specifies a set of methods that any class implementing the interface must provide.
A contract, so it's like a set of rules that classes have to follow.
Exactly. It's like saying, if you want to be part of this club, you have to agree to these terms.
Okay. I can see how that would be useful for enforcing consistency in your code.
Exactly. For example, you might have an interface called drawable with a method called draw. Any class that implements the drawable interface must provide a draw method that specifies how to draw that object.
So whether it's a circle, a square, or a triangle, if it wants to be drawable, it has to have a draw method.
Exactly. It's all about defining clear expectations and ensuring that different parts of your code can work together seamlessly.
Okay, so abstract classes are like templates with some rules, and interfaces are like sets of rules. What's the advantage of using these concepts? Why not just stick with regular classes and inheritance?
Well, abstract classes and interfaces provide several benefits. They promote code reusability, modularity, and flexibility. They also help enforce good coding practices and make your code easier to maintain and extend.
Okay, those all sound like good things.
They are. They're essential tools for building large, complex software systems.
All right, so we've been talking a lot about this person example, but I'm curious, what are some other real-world scenarios where inheritance is used? I mean, how does this stuff play out in the apps and websites we use every day?
Oh, inheritance is everywhere. You just might not realize it's there working behind the scenes.
Give me some examples.
Well, think about a GUI framework like Java Swing or Java FX.
Okay, those are used for building graphical user interfaces, right?
Exactly. They use inheritance extensively to create all the different components, buttons, text fields, labels, windows, all the things that make up a graphical user interface.
So all those buttons and windows we click on, they're all built using inheritance.
Exactly. Each component inherits from a base class that defines common attributes and methods, and then each specific component adds its own specialized functionality.
Wow. I never really thought about it like that.
Mhm.
What about something like a game engine? I'm guessing inheritance plays a big role there, too.
Absolutely. Game engines rely heavily on inheritance to create all the different game objects, characters, enemies, weapons, items, environments, and to define the relationships between them.
So it's like inheritance is the secret sauce that makes all these complex software systems possible.
It's definitely one of the key ingredients. It's a powerful tool for creating elegant, efficient, and maintainable code.
I'm starting to see the world of code in a whole new light now.
Mm-hmm.
It's amazing how much we take for granted.
Right. It's easy to forget how much complexity is hidden beneath the surface.
I'm feeling pretty energized after that segment. It's incredible how much this one concept, inheritance, impacts the software we use every day.
It really is a testament to the power of good design.
I think we've covered a lot of ground, but there's still more to explore.
Always more to learn.
Should we take a quick pause and come back for the final part of our deep dive?
Sounds like a plan.
Okay, so we're back and ready to wrap up our deep dive into inheritance.
I'm excited to tie it all together.
Me too. Now, in the last part, we talked about how inheritance is like this secret ingredient that makes so much of the software we use every day possible.
It's really about creating systems that can evolve and adapt over time.
And our source material actually highlights some of the key benefits of using inheritance. They talk about how it helps us avoid redundancy, which, as we discussed, makes our code cleaner and easier to manage.
Definitely. And they also emphasize how inheritance enables specialization.
Right, so each subclass can be tailored for its specific role while still sharing those common traits with its parent class.
It's like a family recipe where each generation adds their own twist, but the core ingredients remain the same.
I like that analogy.
And this ties into another benefit. The source mentions that inheritance leads to a more intuitive design.
Because it mirrors those real-world relationships.
Exactly. The code becomes more readable and logical, even for someone who's not a programmer.
It's not just about pleasing the computer.
It's about making the code understandable for humans, too.
Now, before we wrap things up, I wanted to circle back to something you mentioned earlier about inheritance being like building with Legos.
Ah, yes, a classic analogy.
It really got me thinking about all the different ways this concept can be applied. And our source provides a link to the full Java code for that person example and all its subclasses. I definitely encourage our listeners to check it out and maybe even play around with the code themselves.
Absolutely. Nothing beats hands-on experience when it comes to learning.
Now, for a final thought to leave our listeners with, do you have any questions or insights that might inspire them to see inheritance in a new light?
Well, here's a challenge. Think about building an online store. What kind of class hierarchy would you design for something like that?
Well, that's a good one.
What sorts of parent classes and subclasses would you need to represent all the different elements, products, customers, shopping carts, payment methods?
So many moving parts.
Exactly. And how could you use inheritance to create a system that's both flexible and robust?
That's a fantastic question. It really highlights how inheritance isn't just an abstract concept. It's a practical tool that can help us solve real-world problems.
It's all about finding those patterns and relationships that can help us structure our code in a way that's both powerful and elegant.
Well, on that note, I think we've reached the end of our deep dive into inheritance. It's been an enlightening journey for me.
It's always a pleasure to talk about this stuff.
A huge thank you to our expert for guiding us through this complex topic with such clarity and passion.
My pleasure.
And, of course, thank you to all our listeners for joining us on this adventure. Until next time, happy coding, everyone.